I thought in the beginning that I would actually put a serious piece together on this, and it is serious, but I was in awe when I started looking at the presentations that you're going to be hearing this afternoon, and I decided, well, I can set the stage without burning up a lot of time, but give you some impressions about the importance of using regional geophysical data to get to the right place, because as a number of my colleagues, and Tom Whiting, I remember, was particularly passionate about this. He says, it doesn't really matter how good an explorer you are. If you're not in the right place, you're never going to find the deposits. And I mean, that seems to be a trivial sort of throwaway thing, but we spent a lot of time inside BHP trying to tame regional data to help guide us to those right places. We were the first to basically compile aeromagnetic data for the whole world. And I remember talking with a colleague just 4 days ago, the difficulties of mapping cover in Australia. And he says, well, Geoscience Australia says we can't actually use depth of basement reliably from magnetic surveys. And I remember, I think it was one afternoon in 1993, I was in the Hawthorne office, Melbourne office of BHP. I was based there at the time. And we had just installed the Naughty depth imaging software we purchased from CGG. And we had a stitch of Australia, and we ran Naughty over the data set over the weekend. And we had all the basins in Australia defined, probably within 20%, on that 8.5 by 11 or A4 size piece of paper on that afternoon in 1993. So for people to tell me now that we can't do something is like, no, we can do it. We have done it. Maybe we've lost it, maybe we've forgotten it, maybe we didn't know how to use it. And I think that's often the case, is we generate information, we simply, in the context of where we're standing at the moment, just doesn't light up. It doesn't take us to the next step. It's an action step. And this is where I think, I hope, in the sort of presentations you'll see today, that a lot of this is now actionable information. You will see things, and it isn't giving up geology, it's enhancing the understanding of geology in a very fundamental level. It's not that you do one or the other. You really should be doing both to get the right story. Being in the right place, this isn't really exactly regional data, but I liked it. Gravity profile over Olympic Dam, and the detailed work. I mean, this is rough as guts, but it's a big deposit. I think it was 17 milligal feature. And if you do get to the right place, good things can happen afterwards. Well, at least from a mining perspective, good things can happen. Certainly to the economy of South Australia, something good is happening. That's probably why Stefan's here today. The taxes for something like Olympic Dam. So, but if you know a bit about the history and the background and the geological thinking, they were pulling a model in from Africa that really wasn't appropriate for the area, but they had open minds about how to use regional data. Structural information is very important, big minimums, things like that. So what I see in an industry is we've been extremely successful for a long time with very, call it traditional or accepted or proven ways of doing the work. And in some cases, we had a session here a few years ago on exploration in Chile, and sort of follow the Yellow Brick Road or follow the West Fisher seemed to be, this is the truism. You do that, it's all going to come good. You may not find anything, but at least you're not doing something incorrectly. It's like a soldier being told, you always have to wear the brightest uniform possible because that's the right way to go into battle. The fact that you're a better target, well, that just sucks. That's just the way it is. So if we, as the Native Americans, we're very good at hunting buffalo, but once the buffalo are gone, things pretty well have to change. And I think the regional data is helping drive that. This, that's like one of Richard Shoddy's images. Cam McQuaig has generated these now ingrained onto our t-shirts and our tattoos for some of us. Camp scale decisions. On the left-hand side, it's open slather. You're not constrained anything really except by your ideas and how you work with regional data typically. Once you get down onto the right side, it's almost as if you're driven by hormones. There's not much you can do other than go find some targets and drill holes. And it doesn't matter if it's the right place or not. Nobody really wants to have that discussion. People have told me time and again, whether it's a junior company, guy in the hallway said, I'm getting majors coming to me now. He says, we want drill-ready targets. And he says, I couldn't even get the time of day from these people like 2 months ago. And where have I got the money to do drill-ready targets? So, rushing up that door once you get down there. And of course, I like the analogy, well, it'll come up. Being incredibly optimistic, we have a low expectation of failure. I think that's one of the things that when I look at the behaviors that we have to change, and using it through regional data should hopefully help. We have to break out of this failure dynamic, I think I'd call it. Because once we call in the SWAT team, you know, it doesn't matter whether it's the little old lady crocheting or the meth guys. We're going to go through the door and everybody's going to be on the floor with handcuffs on in 10 seconds or they're dead. That's the way we conduct exploration. It's extremely efficient, but the higher brain functions have been turned off by the time we get to that point. The time we bring in the VTEM and the Titan, multi-element geochemistry. We're just going through the process. We've already decided there's a bad guy in the building. Oh shit, we got the wrong address. Here's the image that I was discussing last week, you know, with the basins and uncover. Great regional data developing in Australia. We have some great data sets in Canada. Maybe not quite as easy to get in some of the jurisdictions. Fine, it took us a month and a half to get all the data from Quebec. And it wasn't that painful, and now we can work with it. You go to the BC site, and you can download the stuff probably in an afternoon. So, in terms of cost of original primary data, you're still getting tens or hundreds of millions of dollars worth of information for a little bit of effort. And there are, you know, groups like ourselves and others that are quite capable of doing that for you if you don't want the pain. But you got to start thinking about, in that case, the 80% of the continent that's undercover. And regional will help. I put this together a couple of years ago at the behest of a guy running a technical session at the SEG Keystone meeting. Footprints. And we've spent most of our careers, my career, targeting down here. We assume one of these elephants, we hope, but sometimes a gazelle, sometimes a fox or a shrew is what is in there. We spend very little time thinking about how it got there and maybe what came out the tailpipe afterwards. We think about that, but really, if we are going to get better, the regional data will hopefully start giving us some idea as to this much larger geological edifice. Subtle responses, but ones that we can still put together and call a footpath or a footprint that we can trace out. Being close to the data, I mean, this is kind of you could call it a bit of a corny one. A couple of guys in ties, and this was a minerals office. It was PG&Ws in the early 1984. Colin Reeves and Fraser Grant. All hand contoured. A lot of it black and white. They had pencil crayons. But what are they doing? They're thinking and talking about the result. They're not sitting in front of a computer screen in some sort of solitary isolation chamber doing their thing. They're actually talking together about the data. Geophysicist and geologist. Good to see more of that. We can generate these ad nauseum. Don't mean much until somebody takes ownership of it. This is one of these, boy, I wish I had one of these in my property things. This is this cross-section through Olympic Dam. You've got the deposit up here. Scale bar here is roughly 40 clicks. We're superimposing an MT outcome along with seismic information. They call this a textureless zone, so it's sort of been disrupted. The structure's been lost in here. But you say, is this the footprint, this connectivity feature associated with this deposit? Well, if you go back and you find the guy who actually put it together, he was actually at this meeting, Mike Haywood. He says, we had that at Western Mining. We had it at the time, and we went out and looked for analogs. He says it was very hard, you know. And that's one of the things that we have to watch out for, is the belief that the response we get over the first deposit, and if it's positive, try and take that and replicate it without turning off your thought process, you are probably going to be led down a garden path. And it's going to be, then you'll get to the targeting stage, and you're just drilling a lot of holes on things that you really don't know what's going on with. So, it's not that this isn't true, but we probably don't understand the complexity that went into making that in the first place. And so we somehow think the whole thing is interlinked in some sort of genetic relationship, and it probably is, but there's just simply a lot more going on. So the next one could look quite different for reasons that we haven't quite figured out. I'll finish off with one that I liked. This was the GSC. You know, it's a good Eastern Canadian government organization. They got feeling guilty in the early 60s. They started their aeromag program in the late 40s. And I believe this was the part of the first aeromag survey that they had run in Western Canada, British Columbia, my home province. And they did, I think, 5 or 6 sheets in northern Vancouver Island. And at that time, that part of Vancouver Island was known for skarns. There was a skarn district, Mary Widow to the south, some small mining, but nothing really, not even a tier 2 type deposit. But this image was the sort of contouring that they could produce at the time, and the Island Copper deposit was sitting right there. So I came up as a uni student in my second year and worked there, and then I ended up joining the group a couple of years later as call it a junior geophysicist in a whole office of geologists. And the closest thing to a geophysicist was a guy with an electronics engineering degree sitting down in San Francisco. So that was my mentoring. Room full of geologists, buckets of them. So I put a little bit of a story together around this, and I asked people, what did this image mean to you? And this is a little bit of what happened when I asked them. Say, what significance would this had in the discovery of the deposit? And so Geoscience BC, to their credit, well, I guess, went in and reestablished that anomaly, 70 years later. And it's still there, which is interesting because they have dug a big hole there, but that's not the discussion for today. So, courtesy of Tien Grau, the USGS, I've got the 5 mice. So what did the 5 mice think about it all? And this was the responses I literally got from the geologists involved. One of them said, well, it's close to the Red Island Skarn, which is a really tiny skarn deposit. And so that must make that anomaly good. One guy, who turned out to be my father-in-law eventually, he said, well, the really important thing, nothing to do with geophysics, it was the copper geochem. That's why we found the deposit. One geologist was a little more geological, and he said, oh man, it was that guy that came up from Tucson and told us all about the coarse sericite porphyry in the creek. And then, of course, there was one guy who said, oh, well, the magpie was there. It was actually the prospector who found it. He looked at the magpie and then found a tree trunk with some chalcopyrite in it. And, of course, there's always one or a few, they just go along for the ride. So eventually, you put the whole thing together, and who was right? What impact did that regional data have? Well, it assisted in building confidence that there was something of size there in that particular area. And then each one of these other things were tangible contributions, but no one thing was the critical issue. And I think that was the thing, is when you had the input of all of those different components, in effect, hung together by the regional data, then it was a way of making a discovery. So, last slide, I came up with this in a bar about just before Christmas with a colleague. So this is what I defined my perfect explorer, and I just thought I'd share that with you. So we're going to get on to the good part of the sessions, the first speaker.